Hello and welcome everybody to this session. And my name's Sandy Tudhope. I'm from the University of Edinburgh, and it's my honour to be chairing a panel discussion that's looking at integrating nature-based solutions across landscapes and seascapes. And this is where we're going to try to get below the surface to look at some of the challenges as well as some of the opportunities that exist with these nature-based solutions. And we have 5 panel members that I'm going to introduce in turn when they're about to make a brief presentation. But these panel members represent academia, they represent different scales of intervention from local to global and different geographies from the UK again to a global sense. They represent academia and they also represent action and policy-based NGOs. So the format for the dialogue session today is that I'm going to ask each of the panel members in turn to offer a 5-minute presentation where they'll summarize some high-level perspectives from their area of expertise. I will introduce them immediately prior to their intervention. Following that round robin of everybody giving an intervention, I will then ask each of these panel members a single question just to get the dialogue going, because this is our opportunity to have a panel discussion. But then we'll be drawing on questions from the audience and using the questions from the audience to then fuel the discussion for panel members. So if you're in the audience and you've got a question, please identify who you'd like to ask it to, if possible. So with that brief introduction, it's my honour to invite Felix Eigenbrod from the University of Southampton to give our first presentation. So Felix, I believe you're going to tell us about spatial targeting of nature-based solutions and reforestation in Britain. So I'll pass over to Felix. Thank you.
Thank you very much, Sandy, and thank you everyone for the invite here today. So yes, my name is Felix Eigenbrod. I'm a professor in geography and environmental science at the University of Southampton. I'm going to be talking about work I did with a lot of other people, well, mostly done by Beck Spake on ERC-funded research, but also in collaboration with quite a lot of other people. So we all recognize the value that nature-based solutions can sort of provide us. But one of the things which is difficult about them is that the different things work in different places. So this landscape is in the Peak District in England, and what might work up in these hills might well not work in the valley. So I'm just going to talk a little bit about some work we've done trying to overcome this issue. So if we can get the next slide. So one of the reasons for this is that we have to do sort of spatial targeting. Is essentially that spatial trade-offs between different natural capital outcomes, which is essentially nature-based solutions, for example, such as afforestation, will be context dependent. So this is an example from years ago, which I did actually up in Sheffield, which basically shows that if you look in the UK, in some parts of the country, so in the southeast, there's a positive relationship between biodiversity and carbon, because the biodiversity and the carbon are both found in the forests and the lowlands. But if you get to the uplands of the UK, such as in the Peak District or in Scotland, the relationship is actually negative, because most of the peat is found in the soils, in the upland peat bogs, which are actually relatively species poor. So you can't generalize the relationship. It's context dependent. And on the next slide, I'll just show a bit more about that. So one of the things I'm interested in as a sort of spatial ecologist and geographer is questions of scale. So the premise of the research presenting was basically that if we thought carefully about scale, we could overcome this issue of context dependency and understand these drivers of different natural capital or ecosystem service outcomes. So different nature-based solutions for delivering these. And this enables spatially targeting of nature-based solutions, such as, for example, as the very large afforestation schemes planned for the UK. So if we go to the next slide. So this is work, again, as I said, that Beck's led, where we essentially came up with a framework, an analytical framework, which overcame this issue of context dependency by statistically incorporating cross-scale interactions into our models. So basically what this means is a theory that comes from sort of landscape and macroecology, is that you've got different processes operate at different scales. So if we think about forests, for example, you've got local management, canopy, the dominant canopy, that how many trees you plant. You also have landscape scale variables, such as, for example, the amount of forest near an existing patch of forest, which will affect things such as movement of organisms or for example, in this case, rhododendron, which is an invasive species of forests. So the amount of forests near existing forests can be a source for other rhododendron. But at the same time, you also have regional scale variables, so operating at larger scales, such as climate. And you can have interactions between these things, and those in turn give you the context dependency. So the next slide just shows you a bit more of that. So what Bex came up with was that not only coming up with these models, which are mixed effect models, which incorporate these interactions between variables at different scales, but actually mapping these things out, what we call effect maps, which allow spatial targeting of nature-based solutions. And essentially they show you that, for example, in the east of England, where rhododendron isn't within its climatic optimum, if you put forests in the land, new forests in the landscapes, you're actually increasing the risk of rhododendron invading existing forests, because it sort of can hop along. Whereas in the west of the country, where things are wetter, rhododendron is everywhere all the time. It doesn't matter what you do. It's gonna get there anyway. So you don't need to worry about it really. Whereas in the east, if you're planting forests, no reason not to plant them, but keep an eye out for rhododendron in existing forests. So I think if we just we can skip the next slide and just go to the last one. So to conclude, we can use, in this case, we used the National Forest Inventory data set, which is a big data set in the UK for this data, and then some statistical analysis, along with careful considerations of scale to help us target nature-based solutions. And we're currently taking this work to link it to process models to try to find the best places for afforestation in the UK. Thank you very much.
Great, thank you very much, Felix. So what I'd like to do now is introduce the next of our panel members, and it's Viola Heinrich from the University of Bristol. And Viola, I think that you're going to tell us about quantifying the spatial patterns of secondary forest carbon sequestration potential in the Brazilian Amazon. So if I can pass over to you now, Viola, thank you.
Hi, yes, thank you, Sandy. Yes, I will talk about that. And I'll be talking about our most recent work, which is based around the second chapter of my thesis, where we used regional and global remote sensing products to quantify the spatial pattern of secondary forest regrowth. If we could have the next slide, please. So just to get us all on the same page and get a working definition of what secondary forests are, these are ones that regrow naturally on previously deforested, now abandoned lands. And there's lots of things that we know about them and why they're important in terms of a nature-based solution. For example, we know that they enable species to recover in terms of their richness and their composition. We also know that across the neotropics, they are great at absorbing carbon, about 11 times faster than old-growth forests in the first 20 years of their regrowth. But we also know that in the Brazilian Amazon, at least, they are currently not protected under key policies that aim to curb deforestation. And as such, in the last decade or so, they were actually most of the total forest loss came from secondary forests. So with that in mind, we also want to know more about their spatial patterns and the impact that climate, but also human disturbance like deforestation has on the regrowth rates of these secondary forests, which we can see on the next slide, where the first thing that we did was split up the Amazon into 4 climate regions based on 3 climate variables, namely precipitation, shortwave radiation, and drought. And you can see the 4 climate regions outlined in the bottom left map here. And then within each of those regions, we then modeled the increase in above ground carbon as a function of the stand age of the secondary forest, which you can see on the right-hand panel for the 4 regions. I've blended 2 of them out because I'll only focus on 2 of them. So if we focus on the southeast region, which is the bottom right-hand panel, we can see in blue the impact that the climate only scenario has on the regrowth rate in this region. This is a region of low precipitation, moderate shortwave radiation, and is relatively drought prone. In addition to that, if we add another dimension, which is analysing the impact of human disturbance, namely fire and repeated deforestation as a result of shifting cultivation, for example, we can see that the impact of these types of human disturbance reduce the regrowth rates by up to 45%, which is shown by the other three coloured curves in that panel D. If we look at another example, the northwest region on the top left, we can see this is a region of high precipitation and low shortwave radiation. And here regrowth rates, firstly, in a climate only, or the ones that only experience the climate, are about 40% higher compared to the southeast region. So we can see here the differences due to climate emerging, but we can also see the impact of human disturbances, which reduce the regrowth rates by about only 20%. Next slide, please. And if we sort of aggregate all of this information, we can begin to understand the gains and losses through time from the beginning of our analysis period, which started all the way back in 1985. And we found that the estimated above ground carbon stock for 2017 was about 294 teragrams of carbon. We also did a little thought experiment and said, well, what would happen if none of the forests experienced any type of disturbance throughout their growth? So we applied the climate-only scenarios to all of the secondary forests, and we found that the potential carbon stock could have been 8% higher if none of these forests had experienced the human disturbances. Next slide, please. And just to go on to some of the key messages that we can gain from this little talk I've given. But finally, firstly, we can see that we can use new and relatively moderate resolution satellite products to capture the changes that are occurring in these what are quite small secondary forests, and this has the potential to be applied elsewhere. We've seen that the secondary forests currently absorb about 12 teragrams of carbon per year, but this is only equivalent to offsetting about 14% of the annual deforestation that occurs in the Amazon over time. We've also shown that fire and repeated deforestation, in addition to that, reduce the regrowth rates by up to 55%, depending on where these human disturbances are occurring. And finally, I think we want to conclude by saying we need the protection and expansion of these secondary forests, and that's what's really key to realising their carbon sink and climate mitigation potential. If you want to know more about our study, you can follow the links I've shown here. And that's all I've got time for now. Thank you.
Wonderful. Thank you very much, Viola. So I'm going to move on now and introduce our third speaker, and it's Alex Chausson from University of Oxford. And Alex, I think you're going to tell us about mapping the effectiveness of nature-based solutions for climate change adaptation. So Alex, can I pass over to you?
That's right, Sandy. Thank you, and thanks to the organizers. So I based the Nature-Based Solutions Initiative in Oxford, and what I'll talk to you about today is nature-based solutions for climate change adaptation. If you could skip the next slide, please. Please move to the next one. Thank you. And what we led an exercise at the initiative to map the evidence based on nature-based solutions to address the impacts of climate change on people and economic sectors in support of adaptation policy. And as you'll see in the next slide, we brought together over 373 studies, and we're now updating that. So we have over 400 studies, and this map shows geographically where the interventions in our database took place. And what you can see from this map, first, is a marked divide between the north and the south, and most interventions we found in the peer-reviewed literature were in Europe, North America, and China. And as the next slide shows, we first grouped the evidence according to intervention type, ecosystem type, and climate impact. And what I want you to focus on is so the top row is the result of the global analysis, and the bottom row of graphs is the update for lower income countries, which we're now working on. But what you see on the top for the global analysis is a large cluster of studies in montane ecosystems. But what was surprising is that few reported on slope hazards. And there was also little evidence in natural grasslands. So those were two key evidence gaps. And another thing to point out is that although there is a lot of evidence on the impacts of coastal ecosystems on climate hazards, what we found is that there are few, at least in the peer-reviewed literature, there are few site-specific evaluations of interventions. The other thing to point out is that we found evidence for a wide range of climate impacts, of 33 in total. So this is how the intervention is addressing those impacts. But most was clustered around water availability, soil erosion, flooding, and the loss of timber or food production. And across lower income countries, not surprisingly, we see a cluster of evidence in tropical ecosystems. And also we see a strong cluster of evidence on the loss of food production, as well as the loss of other ecosystem goods. As the next slide shows, just very quickly, any given intervention can be associated with a broad array of different climate effects. And so this is important to keep in mind. And as the next slide shows, when we look at the effectiveness, the reported effectiveness of these interventions, we see that most reported outcomes were positive. The top graph shows you the global assessment, which I'll focus on now. The thing I want to point out here is that most of the reported negative effects cluster in the water availability category. A large chunk of these came from poorly planned afforestation projects. But our ability to look at synergies across different climate impacts, or the effects on different climate impacts, is limited because most evaluations were narrow, focusing on the effects for one climate impact. Next slide, please. And we looked at the broader outcomes as well on greenhouse gas mitigation and broader social and ecological outcomes. Most of the outcomes were positive. And the evidence does suggest mostly synergies between adaptation, social, and ecological outcomes. But as the graph on the right shows, again, there was an underreporting across different dimensions, which makes it difficult to assess trade-offs or synergies. Next slide, please. I just want to show you here that the left-hand side basically shows interventions involving ecosystem creation, and the right-hand slide shows interventions involving natural or semi-natural ecosystems. And the thing to point out is that we found a trade-off with respect to water availability and soil erosion, as the graph on the left shows. The orange are negative outcomes. So the point here is that interventions that harness natural or semi-natural ecosystems predominantly showed synergies, whereas the opposite was true for ecosystem creation. Most of these were about large afforestation scale projects. Please skip the next slide and go to the last one. Yeah, thank you. So in conclusion, nature-based solutions have the potential to address a range of different climate impacts, but there were key gaps in the evidence base, including a lack of integrated studies. We need more assessments to understand effectiveness, and importantly, to manage risk. What I didn't show you is that we also found evidence of social trade-offs, which is crucial to focus on when implementing intervention. And on that point, I'd guide you to the IUCN Global Standard on Nature-Based Solutions, as well as the 4 evidence guidelines that we co-created with 20 organizations in the United Kingdom to promote sustainable nature-based solutions. Thank you. Last slide. That's it on my end. Yeah.
Great. Thank you very much, Alex. Wonderful. And I'm going to introduce our next speaker, and it's a pleasure to introduce Hugo Tagholm, who's the Chief Executive of the NGO Surfers Against Sewage. He's also a member of the Edinburgh Ocean Leader Programme. And so, Hugo, I believe you're going to tell us about the Ocean and Climate Emergency, Restore and Protect Planet Ocean. Can I pass over to you, Hugo?
Absolutely. Thank you, Sandy, and a real pleasure to join you all here today. And thanks to my fellow speakers. What an exciting week for nature-based solutions, particularly in the public eye, with the announcement of the Jubilee Canopy, with today's announcement about binding species targets, and the announcement, I think, this morning at this very event of the water company investments to restore our very polluted rivers with nature-based solutions. So really exciting times, and very much connected to the work that I do with my team at Surface Against Sewage. And for those of you that don't know, Surface Against Sewage is a national marine conservation and campaigning charity, and we were founded, hence the name, by a group of surfers on the north coast of Cornwall back in 1990. But today we've become one of the most visible ocean protection NGOs in the UK. And we create positive impact by empowering individuals and communities and connecting their voices with business and political leaders to help change the systems around us. But our campaigns generally start at the beach and are rooted in the experiences that people have in, on, and around the ocean. Our campaigns also generally focus on limiting emissions and pollution that affects our seas, which of course goes hand in hand with the urgent need for nature-based solutions to climate change and biodiversity loss, both in marine and terrestrial ecosystems. Without tackling the inputs, our sewage pollution, plastic pollution, pharmaceuticals, toxic chemicals and agricultural waste, the restoration and resilience of ecosystems, the nature-based solutions, will be seriously compromised. Nature-based solutions will only flourish without pollution. So we need to both restore and protect our environment. As we know, climate change is the biggest environmental crisis our blue planet faces, affecting individuals, communities, ecosystems, and species worldwide, and ultimately threatening all life on planet Ocean as we know it. From ocean warming and acidification to biodiversity loss and sea level rise, the impacts of climate change on the ocean are extreme and far-reaching. Shockingly, the findings from our Ocean and Climate Survey reveal that 76% of people believe that the destruction of the ocean environment is a primary driver of climate change. But what should be done? Reducing carbon emissions is something the public and politicians and business leaders have already embraced. Net zero targets are firmly embedded in all business plans. But these reductions alone will not be enough to keep global heating below the required temperature. Large amounts of carbon must also be removed from the atmosphere to compensate from the industrial boom of the last century. Rewilding, restoring and protecting wild carbon habitats must be accelerated at pace. These nature-based solutions. Given the chance and a helping hand, marine environments can thrive again and provide the natural mechanisms to both mitigate climate change and ensure protection against the climate change impacts we can no longer prevent. Although they're among the world's fastest disappearing ecosystems, so-called blue carbon habitats such as salt marshes and seagrass extract and store a vast amount of carbon dioxide and therefore play a pivotal role in addressing the climate crisis. Blue carbon could be one of the most effective yet overlooked and undefined methods of long-term carbon lockdown. Yet so far, rewilding initiatives attract only 2.5% of funding for mitigation and far too little political attention until perhaps today with some of the announcements that are being made. Sadly, current marine protected areas spanning many blue carbon habitats are all too often too lenient and inadequately enforced to provide real protection to our seas and sea life. Extremely damaging extraction processes still regularly take place in these areas, including industrial fishing by super trawlers. Seabed and marine sediment sequester huge volumes of carbon. In fact, a recent landmark report states that they are the world's largest carbon sink. However, industrial bottom trawling of these ecosystems currently release as much carbon as the entire aviation industry. We must implement highly or fully protected marine reserves, completely prohibiting extractive, destructive and industrial uses and allow only non-damaging levels of other activities. We also need to ensure that pollution emissions and inputs are properly regulated and enforced to allow nature-based solutions to take hold and ecosystems to properly recover. Clean blue carbon. The link between ocean and climate change is critical, so it's vital that the ocean's voice is heard amongst all climate action. Thank you.
Wonderful. Thank you, Hugo. A great exposition on the importance of the oceans for us. I'd like to move on then to our final speaker, and is Raj Whitlock from the University of Liverpool. And Raj, I believe you're going to tell us about species-rich meadows as a vital source of nature-based solutions for climate adaptation in conservation and agroecology. So Raj, if I could pass over to you now. Thank you.
Thank you, Sandy. In the next slide, you can see that grasslands come in a variety of different forms. Next slide, please. From the improved grasslands that support our dairy industry on the left and the middle there, through to the unimproved species-rich habitats that are so important to conservation. Grasslands provide us with a wide range of ecosystem services and also nature-based solutions. They support a wide diversity of pollinators that pollinate plants in wild habitats, but also crops. They store carbon in their soil, and they're also the fundamental basis of the arable systems that are the foundation of food security. As with other green spaces, they also have significant roles in amenity and in human well-being. On the next slide, I will explain that grasslands in the UK form a really important store of soil carbon. Around 2 billion tonnes of carbon are stored in a wide range of grassland types up to a metre depth across the British Isles. Of that, 90 million tonnes of carbon are stored in semi-natural grasslands in the top 30 centimetres. Not all grasslands have the same capacity to store carbon, as shown in the graph at the top left there. For instance, acid grasslands store more carbon per unit area than the other grassland types. And even that's not the whole story. Grasslands vary in their soil depth, and the species-rich calcareous grasslands that I'm going to be talking about here have very thin, shallow soils and therefore limited capacity to store carbon. At the same time, the extent or area of these grasslands has been much reduced. What this means is that it will not always be the case that the unimproved species-rich grasslands will make the biggest contribution to carbon storage. So what is their value then? Well, I will argue that the value of these systems to nature-based solutions lies in the tremendous diversity of plants and animals that they support. On the next slide, please. Long-term experimental ecological experiments are an extremely important way of understanding the future value of grasslands to nature-based solutions. What we do is we apply experimental climate change to treatments to a real grassland. This picture shows the Buxton Climate Change Impacts Lab, where climate change treatments have been applied to a grassland for 27 years. From this, we can learn both how nature-based solutions will be altered by future climates, but also we can learn what happens when we expose a real complex grassland ecosystem with all its diversity to climate change. What solutions does this natural system itself provide us with? In the next slide, we can see that in this experiment, we have three main treatments: the drought treatment, the warming treatment, and the watering treatment, all of which have been going since 1993. What about the results? In the next slide, we can see that the climate treatments have sorted species according to their characteristic traits. So on the left-hand side there, we can see species with easy to construct cheap leaves. They've done well under the moisture environments at Buxton, whereas those species on the right-hand side with better defended leaves, tougher leaves, they have been able to persist in the drought treatment. Next slide or animation, please. There are implications to this. We can understand in the future what types of plant species might persist, and therefore we might be able to predict which types of species will allow us to be most resilient in both the high input grassland systems, but also in conservation relevant grasslands. Next slide, please. Climate treatments at Buxton have also driven rapid evolution in plant species, and here we see Festuca ovina. This species that has evolved rapidly under drought treatment, changing the way it produces biomass so that it's more sustainable under climate change, adapting its leaf morphology and adapting the way it reproduces so that it can persist under a drought treatment. Fascinatingly, the genes which control this are not the ones we expect. They relate to plant immunity and plant defense. And therefore, this natural evolution might provide a way of understanding crop improvement in the future and provides novel nature-based solutions. Finally, on the last slide, I will argue, yes, that semi-natural grasslands clearly are valuable carbon stores, but I would also argue that their key value to nature-based solutions lies in their value as a treasure trove of biodiversity and their value to all these other ecosystem services that that nature can provide. We need to understand better the adaptive biological processes that allow these grasslands to respond and adapt and persist in the face of climate change. That will allow us to shape new strategies for climate adaptation and mitigation. Finally, yes, we need experiments and observations to refine our understanding of nature-based solutions, but we also need a joined-up approach to nature-based solutions that doesn't only revolve around soil carbon, exactly as Felix suggested. We need to think much more deeply and strategically about the spread of NbS that we actually want and how the landscape can be configured to deliver that. Thank you.
Wonderful. Thank you very much, Raj. Great insights, and these long-term observations and experiments do provide these fascinating insights. And so what we're going to do now is move into our discussion mode. And what I would invite members of the audience to do is to start populating the spreadsheet with questions. And I've got a helper, Wasim, who's going to be assisting me in identifying questions to ask. But to get the panel discussion going, I'd like to ask each of the panelists a question in order, because they've all given us some fascinating insights, but from very different perspectives, different scales or different locations, different ecosystems, or different motivations, research versus activism and action and policy. And so maybe, Felix, if I could come to you first. Felix, you talked about your statistical spatial models, and I just wondered if you could share some insights into opportunities for integrating that type of spatial modeling approach with other modeling approaches to identify the sweet spots for intervention for nature-based solutions in the context that you work in. And what I'm asking each panelist to do here is provide a 1 or maybe 2 minute maximum response to that. So Felix, can I pass over to you now? Thank you.
Sure. Thank you, Sandy. Yeah, I think that's quite exciting. I think necessary is that getting these nature-based solutions right is going to, I think, require some integration of various different approaches and models, which will require some careful thinking about. One of the things we're interested in at the moment, which is work being funded under the Advances project, under the funded Advances project with lots of collaborators, is thinking of asking the question, if we prioritize our new trees in the UK based on the best places in terms of their carbon uptake, what are the implications for that for the existing the health of the existing forest in terms of the biotic risks? So in risk of invasion by invasive species or deer browsing or tree health. So basically, what are the implications on existing forests of putting new forests in the landscape? And we think the way to do so you can get at most of the carbon stuff mostly through process models. I think not too far away from some of the stuff that Viola was talking about, which is relatively local processes. But then you can, if you link those, or so we're simply looking at the overlaps with these risk maps of different risks, you can then say, well, actually, some places might be riskier than others in terms of carbon. It might be quite good for carbon, but a bit risky in terms of risking the negative impacts on existing forests. And if there's a lot of carbon there, you might still want to do it, but you just might want to think carefully about how you manage those other landscapes. And again, you can overlay that then with other things. So there's work, the econometric modeling, such as what's coming out of Exeter, looking at opportunity maps in terms of the best places in terms of the least impact on farming yields or on farming impacts. You can look at recreational potential. So I think we really need to be a bit careful here, because there is a long history of getting these things spectacularly wrong. So in the UK, we in the 70s, I believe, we decided it was a good idea to put lots of pine plantations in in the uplands of Scotland, which was a complete disaster, because it means you drain the peat out of the trees, start falling over, and you ruin the peat bog, and you release massive amounts of carbon. So we now know, I mean, no one would ever think about planting trees in high carbon in peat bogs anymore. But there are these other things which I think we do need to think about as we think about these very large nature-based solutions that I think will be necessary in the UK and elsewhere to really get us to net zero. So thank you.
Brilliant. Thanks very much, Felix. And that you're coming from Scotland, that example of planting pine on peat bogs is a bit too close to the heart there. So a good example. Viola, I'm going to come to you next. And you gave these really fascinating insights into the secondary growth forests in the Brazilian Amazon and the opportunities that they can present if we start to manage them well for providing nature-based solutions, primarily around climate mitigation, the carbon side of it. Do you want to just tell us a little bit more about the opportunities for that approach to translate to other major forest ecosystems, either tropically or even thinking extratropically? Would you think the same high-level messages come through on secondary forest growth if you're in a kind of semi-dry forest in southern Africa, as opposed to a wet tropical forest in Indonesia, etc.? So just anything that you'd like to explore for us there, Viola?
Yeah, thank you, Sandy. I think I'm going to answer that question in three parts. Firstly, the fact that we were using regional and global remote sensing products, which all relied, the regional one relied on Landsat data, which is available across the globe, suggests that this method can be applied in other regions across the world. And that's sort of where my next step is leading into my research. I'm looking at more of a pan-tropical analysis. But I quickly want to touch upon the applications of these as well, and why we would even want to use this kind of approach in other regions. Partly because we can use the results and the method can be applied to help understand the sort of within REDD+, for example, we heard about that earlier in the day, and how these methods can be used within results-based payments, for example, and that has motivations to be applied in many parts of the world. You mentioned Indonesia and Borneo, and it's important to understand in each of these different regions, forests have a different dynamics and they regrow in different ways. They have different types of disturbance. In Borneo, for example, there's a lot more logging rather than this clear-cut deforestation that we see in the Brazilian Amazon. And if we can use remote sensing products to pick apart these different types of human disturbance and to understand the regrowth and the differences within that can be really beneficial in terms of understanding the carbon recovery. And our preliminary research has shown we're applying the same method in Borneo and as well in Congo. We can see that we can see the differences in terms of the spatial patterns of regrowth emerging, not just from secondary forests, but also from degraded forests in Borneo, for example. So I'm hopeful that this has wider applications and we can utilize these new and emerging remote sensing products. Yeah, thank you.
Wonderful, Viola. I really like that kind of reflection. Context is everything. And you need to understand not only the ecology of the ecosystem you're interested in, but what the drivers of change are. And they can be the external drivers of climate, but there can also be the social and economic drivers, depending on where you are globally and what the reliance of local populations is on the resource and how they utilize it in different ways. So really helpful. So Alex, I think it's kind of following up on this to some extent. Can I come to you now? And the issue of social trade-offs. And I wondered if you would maybe explore for us an example of these kind of social trade-offs that you get when you're considering nature-based solutions for climate.
Yes, thank you. Yeah, so that's a very important point because people are very much part of the landscapes where nature-based solutions are envisioned. And for them to be effective, we need stakeholder support and buy-in. And that requires addressing trade-offs between different stakeholders groups, not just between different outcomes. So one example to zoom in a little bit on some of the studies I mentioned is from Kenya, where if for those of you familiar with Kenya, you might be familiar with conservancy schemes. And in one site on pastoral grazing lands, the establishment of such a conservancy diversified income sources for landowners, and that was through wildlife tourism. The issue was that non-conservancy members, and particularly the landless, so the most marginalized, were not eligible to receive tourism from this payments, from the tourism scheme. As a result, they were negatively impacted by the livestock grazing restrictions which take place on these conservancies. And so the first point is that we need to be aware of this to design more effective interventions. And the most important point is that addressing that is a key part of managing risk to people and ultimately the intervention. So thank you.
Yeah, great. An interesting example from Kenya on the unintended consequences, where you make an intervention with the best of intentions and then find that you're having a negative impact on those who are the most vulnerable, often to the impacts of climate and environmental change. So, salutary tale. Hugo, can I come to you now? So your whole motivation in business is to help bring evidence to bear and bring people to the table to help influence policy and positive outcomes. And I just wondered if you could explore for us a little bit more what you see as the real opportunities for getting the public more involved in the need to restore and rewild the ocean.
Yeah, absolutely, Sandy. And just to sort of build out from the previous question, I think it's really relevant because this is about bringing stakeholders together to see the benefits of nature-based solutions and the restoration of our environment. And we must surely be in the decade where we move from shifting baseline syndrome to lifting baseline syndrome, and we show people the increasing benefits that the restoration of nature gives them. And the fisher community, I think, is a good example of that, and there are examples around the world where the implementation of highly protected marine areas, which can be a very controversial thing, done in the right way, bringing the right people together, can show a win for nature, a win for the fishing community and industry, and a good impact for ecotourism and other economic sort of drivers. And I think that the public now is ready to be on this journey. They are environmentally sensitive. We're seeing now a big alignment between government drivers, business drivers, and public intent, and they want to be part of this journey. And we can engage them from the beachfront, right through to the mountaintop with actions. And they're starting to see that their actions are connected with the protection of those spaces that they love most, which is exactly the sort of environments we're talking about: our forests, our rivers, our coastal zones. These are places that have been proven, particularly during the pandemic, to be so close to people's hearts and so important for their physical and mental well-being. So I think we're seeing this convergence between lots of different issues coming together, which can be rooted and founded upon the restoration of nature.
Great. Thank you very much, Hugo. And so, Raj, I'm going to come to you next. So you really nicely touched on the issue about using natural ecosystems or nature-based solutions for the carbon mitigation side of things, the climate mitigation. But you emphasized the importance of the other ecosystem services that grasslands and associated ecosystems provide. And I just want to offer you the opportunity to explore that a little bit more, because I do sense there's certainly a lot of businesses who are business and organizations who are trying to achieve net zero, and they're thinking how they're going to do it. And they're thinking, oh, I'll tell you what, we'll just do it with some approach that focuses on the carbon issue. We want to offset so many tons of carbon per annum by this year. And that is the main focus. So maybe if you could explain to us or offer some perspectives on getting the balance right between the carbon side of the equation and the whole wider ecosystem benefits.
Thank you, Sandy. That's a really tough question. So I think the first thing I'd say that the journey towards net zero is extremely important. And so I welcome the announcements that have been made today that will allow us to commit towards nature-based solutions that protect peat bogs and expansion of woodland area via tree planting. What I would say beyond that is that the other ecosystem services or nature-based solutions, whatever we want to call them, can be extremely important. And our existence as a society depends on these other services as well that nature is able to give us. So while the nature-based solutions around carbon are extremely important, it's also critical that we get the balance right. It's imperative we do that because that will dramatically affect the nature of the world that we live in. And I think, what's what's really needed, in my view, is a very strategic approach, even at the policy level, that doesn't deal with habitats on a piecemeal basis, one by one, but looks at the integration and the spread of benefits that we want to see from nature. Unless we do that, there is a significant risk of perverse outcomes from the implementation of nature-based solution strategies. And I tried to kind of make that point in my presentation. It's also worth thinking beyond the countryside, and I think here especially grasslands can have a role to play in the centre of urban environments, particularly with access to high quality green spaces where we can learn from nature and also derive well-being benefits. So I think there's some of the work that we've seen in the other presentations will feed through to defining what those strategies are. But I also think that it's important at the policy level that we begin to think very strategically and in a joined up way in order to get these nature-based solutions right.
Great. Thank you very much, Raj. So I'd encourage anybody in the audience who's got questions to ask, to make sure that you fire them in and they'll get transferred through to us. But in the meantime, I'm just going to keep the discussion going. And I think I observed that the big UN conventions around biodiversity and climate, I think in the past, it's fair to say, have been somewhat parallel rather than integrated. And yet what we're talking around here, and also bringing society in it, is looking more explicitly for where you can have interventions that are going to benefit not only climate, but are going to benefit biodiversity and ecosystems, but are also going to be consistent with a just and equitable and supportive reduction of social and economic inequalities for societies that depend on these ecosystems. And I'd be fascinated to hear. Maybe I'll go around to each of you and just ask, what is the thing that gives you the most hope in terms of using the ecosystem-based approach? I'll give everybody a minute to reflect on that. But if you're thinking of what we've learned so far about nature-based solutions, you're thinking, right, in my imagination, this is the opportunity to do something really big. So could I ask you all to reflect on what would be your top priority, your big opportunity that you see? And I'm going to come to you first, Felix, but I'll give you a minute just to reflect on that. Whenever you're ready, Felix.
I think I'm ready. I think the biggest opportunity probably comes, so it has to be done very carefully, in these what are called marginal lands, where you've got marginal agricultural, certainly terrestrial ones. I don't pretend to know anything about the oceans. I'll leave that to Hugo. But on terrestrial lands, I think there are opportunities where we've got, well, for example, in the UK, where we've got where we've got agricultural systems that have been to some extent propped up by subsidies, or agricultural practices that have been propped up by subsidies, where if we just change those subsidies around, we could put in place, things that suck up a lot of carbon, have great benefits for biodiversity, and as well as for people if we put them in the right places. Again, all of this needs to be done really carefully. So, for example, the uplands much of the farming in the uplands of the UK is unprofitable. Really, it's propped up by subsidies. So, if one removed those in one fell swoop, as could happen under some Brexit scenarios, that would probably give us a lot of forests, but it would also, it would completely devastate those rural communities. It would also, and I think people would be quite upset to see such drastic change across, these iconic landscapes like the Lake District. But at the same time, I think some level, in some places, that's probably fine. We can do some of that quite easily with, I think, minimal trade-offs. There's always going to be trade-offs, but I think those kinds of opportunities where the economics work, I think that there is some hope there. I think those are some pretty interesting ones that I think we probably worth focusing on. Great.
Thanks very much, Felix. That's obviously so timely just now when there is this there's push for massive reforestation within the UK, and obviously the impression that this could perhaps be utilised globally as a significant drawdown of carbon. But as you say, there's always trade-offs, and I think it's being explicit around understanding these trade-offs and not viewing it as a simple black and white and easy thing to solve. Great. Viola, can I pass over to you next?
Yeah, I think sort of following on from that, what gives me hope in terms of nature-based solutions and their sort of potential future as well is that we're talking about not just planting trees to suck up carbon, we're talking about growing trees so that they have long-term benefits for other people to enjoy, to gain benefits from them, whether that's for economic value or for recreational, more in the UK probably. I think given that we're shifting the conversation more towards sort of the co-benefits of all of these nature-based solutions, is my hope that these trees will not just be planted and just sit there, but also be used for a long time, because we're talking about these in terms of, the climate benefits. We need these trees to be there, or the forest or the nature to be there for a long time for them to have any carbon benefit in that regard. So if we can combine that with other co-benefits, I think they will actually have a chance of serving their multiple purposes.
Wonderful. Thanks very much, Viola. Felix, can I come back to you? So you've got your hand up.
Yeah, I just want to say this is something which also Alex touched on, that just talking about planting trees, I think it's really, really, really important that people don't see, no matter where we put a tree, it's a good thing. In some cases, as Alex pointed out, if you put trees in places where they're not supposed to be, so in savanna systems, which aren't really, it's one thing to restore forests, and I guess, as Viola was saying, particularly if you can assist forests in natural regeneration or just allow them to regenerate, that's generally a very good thing, with some caveats of trade-offs. But sticking trees in places where they're not supposed to be, such as peatlands or trying to reforest the savannas of Africa, there have been some quite simple analyses, is just a truly terrible idea. So as of all of these things, the right place, tree planting is a great idea, but not everywhere, not all the time. And actually, it's better to let forests come back naturally if you can, rather than planting them.
Brilliant. Thanks very much, Felix. So, Alex, can I come to you next?
Yes, I'll just follow up on that very quickly. I rushed the presentation a little bit because of the time restrictions, but that's very much the point. And in fact, a large proportion of these studies where I discussed the trade-offs with water availability and other outcomes like soil erosion were precisely large-scale afforestation policies which didn't pay attention to the ecological context, and they were in semi-arid or arid regions. And therefore, they depleted the water table, and ultimately what this does is it's not only bad for biodiversity and often local livelihoods, it's also bad for the intervention itself. The trees they can die as a result of depleting their own environment, so to speak. So I just wanted to follow up on that. And from my perspective, I'll take in terms of your question that you asked, Sandy, I'll take a step back and just say that what I'm optimistic about is that this discussion on nature-based solutions is also an opportunity to reframe and rebalance our relationship with nature, or at least to critically reflect on what that is currently and what that may look like. To understand our dependency on nature, but also, and very importantly, how we can work with nature. We talk about nature-based solutions. Ultimately, we have to understand that there have to be people as a part of the equation to make those systems work. We can talk about it from the ecological or the social standpoint or the economic one. Ultimately, though, it's very much about place-based interventions of people working with nature. So that's the point I'll make.
Great, I really like that. Yeah, the place-based interventions with people in nature. Hugo, can I come to you to offer your perspectives, and then we'll go to Raj, and then we've got a question from the audience as well. Thank you.
Absolutely, and I would continue on from Alex's points. I think in the marine environment, I think we have a good opportunity for nature to rebound on its own accord if we stop some of the destructive practices that are damaging so much of the marine ecosystem. And I wonder, there's a lot of talk at the moment, of course, around public money for public goods, landowners and farmers being now incentivized to restore nature. Now, I think maybe we should be looking more and more at public money for public good in the blue and marine spaces to mobilize the fisher community and other parts of the marine stakeholder community to help protect and monitor and actually safeguard the spaces that have the biggest chances of rebounding naturally without any planting, without any other intervention, but just have the right conditions to combat themselves, because then the marine environment is proven to actually rebound pretty quickly when it's allowed to. So whether it's our seagrass meadows, kelp forests, salt marshes, finding the, as it were, poacher turned gamekeeper sort of analogy to really accelerate that transition during this critical ocean decade.
Great, thanks very much, Hugo. And you just mentioned there, obviously, this is the UN Decade of Ocean Restoration. It's also the UN Decade of Ocean Science for Sustainable Development. And both rather explicitly trying to bridge between the science of understanding the ecosystems, but the fact that humans are part of the system and we need to think about it. I like that poacher turned gamekeeper, because that's certainly, I think, a lesson that's been learned from marine conservation. If you don't get the fishermen on side in some degree as the agents of positive change, then it's uphill to try to protect marine areas. Absolutely. Raj, can I come to you and then we'll ask our question from the audience? Thank you.
Thanks, Andy. I think what gives me hope is the change in the understanding or appetite for nature and the solutions it offers to us that's, I think, has happened in the last couple of years. If there is a silver lining to the horrible COVID around crisis that we're currently going through, that might be one of those silver linings. We're much more aware of nature and its importance to us, and we have an appetite for change. And I think that presents a really important opportunity for us. And it also provides a challenge for us as ecologists as to, to guide this in the right way and make sure, as the other speakers have highlighted, that the right interventions are conducted in the right places. To give an example around pollination resources, the majority of the nectar resource in the UK is concentrated in just a small handful of plant species, one of those being white clover, one of the components of the most improved grasslands. Now, if we could improve the diversity of those swards just a little, then we could greatly improve the support for pollinators from grasslands. So that awareness of the importance of nature can allow a vehicle for those kinds of change. And I guess the challenge is just to be able to guide that, both as the information we can feed through as ecologists and the sort of integration of that at the policy level.
Great. Thanks very much, Raj. So I'd like to ask a question from Isabel. How do we balance maximizing ecosystem service delivery value, such as carbon sequestration, with maintaining biodiversity, even among species that are perceived as less valuable, so their conservation is less justified under the NbS approach? So I think it is speaking to the heart of this issue of balancing carbon versus species. But pointing specifically to some species which might not be viewed as at risk and therefore undervalued in some way. Would anybody like to pick up that question? If so, could you stick your hand up? Maybe I'll just ask Felix. Oh yes, Viola, perfect, thank you.
I was just sort of, it leads on from what Raj already said, is sort of applying the right approach in the right place. And I think often it's a matter of, there's so many studies and so much research out there that already tells us about the balancing. It's a balancing act, but also it's a matter of listening to people on the ground, listening to the locals, and listening to what they know about the balance between the ecosystem and the ecosystem potential, but also the biodiversity benefits. So I think it's a question of, as Raj says, putting placing the nature-based solution in the right place, and there's not a one-size-fits-all, as we've already said throughout the talk. And I think that would hopefully get us in the right way to find that balance. But I think Raj wants to carry on from that.
Thanks very much, Viola. I'm actually going to ask another question that's come through, Raj, so thanks, but I would like to get this one from Gayatri Petkar, and they ask, what are the risks of bio-waste treatment on the environment? So what are the risks of bio-waste treatment on the environment? And again, we're nearly out of time, so is there anybody that feels motivated to help answer that one? So I'm not getting any offers.
Can we just define bio-waste specifically?
I'm not sure we've got an easy means to do that.
I mean, I would just take it from the point of view of the disposal of sewage and agricultural waste, and everything that transports with it. So even when we treat it, it still can take a lot of pathogens and toxins into the environment. We've done some work with the European Centre for the Environment and Human Health on the antibiotic-resistant bacteria that find their way into our waterways through bio-waste, sewage and agricultural runoff. And it's shown that in regular bathers, swimmers, surfers who get into water close to particularly river mouths, that they have a 3 times the level of antibiotic-resistant bacteria in their gut. So clearly another sort of huge threat to our society, antibiotic resistant. So it is a really, really big issue.
Wonderful. Thank you for picking that up, Hugo, and I think you nailed that. It was exactly a good track to go down. So we're out of time, so it's just an opportunity for me to thank all the panelists. I really enjoyed that, and to thank the audience. It's going to be hard for me to summarize other than to say, I think we learned that context is everything, that you don't think of one dimension like carbon or biodiversity or people. You have to think about it as an integrated system, and that an intervention in one place may not be applicable in another. So you have to think very carefully. But I think we also learned that there's an opportunity for us to re-examine the relationship of people with nature, and to think of that in a positive sense. So I definitely came away from this with a sense of optimism that the future is there for us to define and us to help shape by working with nature and not against nature, so as part of the system. So with that, I will finish off because we're now out of time. So thank you all very much, and thank you to all those behind the scenes that organized this for us. Thank you and goodbye.
Thank you.